Hello everyone. For this tutorial video, I'd like to demonstrate how you can compute integrals involving complex trig functions using trig identities as well as calculus techniques such as substitution. For example, if we were asked to integrate sine to the fifth power of x with respect to x, we would do this by first isolating one of the sine of x's, then seeing sine to the fourth power is sine to the second power squared, and we know sine to the second power is 1 minus cosine to the second power. So we plug this in under the squared sign, seeing we can do a u substitution where u equals cosine of x, expanding everything under the squared sign, doing the integral using the power rule, and then simply plugging in cosine of x for u, and we get our final answer for the value of the integral. If we have this integral instead, with a power of sine and a power of cosine, we would first isolate one of the cosines, so that cosine to the second power is 1 minus sine to the second power, doing a u substitution of u equals sine of x, distributing the u to the power of 6 in the two terms, computing the integral using the power rule, and finally plugging back in sine of x for u. You can use trig identities for sine squared, cosine squared, as well as sine times cosine, in order to rewrite integrals. For example, if we are given the integral of sine to the second power and cosine to the second power with respect to x, we could substitute in the formulas individually, and then simplify algebraically. Then use the formula again for the cosine squared in our simpler answer, distribute the 1/2 in the parentheses, compute the integral, and then distribute the constant of 1/4. Or we could do it as, noticing that two terms squared individually is the same thing as the product of them squared. So we rewrite this as sine of x times cosine of x squared, use the formula for sine times cosine, take the constant of 1/2 squared equals 1/4 out of the integral, use the formula for sine squared, and finally compute the integral. You will see, even though they use two different methods, both of them give you the same final result, as you should expect because you are integrating the same function. Now that we have seen examples of integrals involving trig identities as well as u substitution, we can talk about integrals that involve substitution in terms of replacing x's with angles in the next tutorial video. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.